remember you saying, and this is kind of amazing, that after you win the Nobel Prize, you thought that this mission was the most important thing to work on.
Absolutely. It's the next question. After you know how it started, what happened then? And, suddenly we now have the technology to do it. We didn't have 50 years ago. We didn't have the technology 25 years ago, even when we started this. We had to invent things along the way, so we did that. And here it is.
In the summer of 2022, just weeks after the James Webb Space Telescope began returning its first scientific images, astronomers noticed something odd. Scattered across the deep fields were tiny, brilliant red points of light, objects Hubble had never seen, and in theory shouldn't exist in such large numbers. They weren't galaxies as we knew them. They weren't stars. And one of them would later be named the Cliff. This strange thing has opened the door to something far stranger, one that leads to a radical new idea astronomers can no longer ignore. In astronomy, calling something very red means it emits most of its light in long wavelengths, especially in the infrared. And some of these little red dots emit much of their light beyond 10 microns, far beyond what Hubble's instruments could detect. JWST, however, was built for exactly this kind of light. Its infrared sensitivity is so high that it can see objects whose glow has been stretched by the expanding universe for billions of years. That's why these compact, ultra-red dots suddenly appeared. They weren't new. JWST was simply the first telescope capable of noticing them. And so, the attempts to explain the little red dots began. One idea was that these objects were galaxies, filled with enormous numbers of stars, so compact and dust-enshrouded that they appeared extremely red. Think about the space around our sun. If you traveled a few light years in any direction, you'd still be mostly surrounded by empty space. But in these proposed galaxies, stars would be packed so tightly that neighbors would sit incredibly close, not light years apart. In a galaxy that dense, the night sky would glow constantly, filled with the light of thousands of nearby stars. This explanation, however, demanded impossibly large masses, only a few 100 million years after the Big Bang. Too early and too extreme, even for aggressive galaxy formation models. The galaxy theory began to strain under its own weight, and so astronomers looked elsewhere. Black holes. The competing theory claimed the dots were active galactic nuclei, black holes feeding rapidly, surrounded by hot accretion disks. If these black holes were heavily obscured by dust, they could appear red. But this explanation too met with contradictions. The spectral signatures didn't match known active galactic nuclei. The number of dots implied far more supermassive black holes in the early universe than what our theories suggest is possible. In short, both theories fell short, and astronomers hit a roadblock. But then, something remarkable happened. In 2024, the RUBIES program, short for Red Unknown's Bright Infrared Extragalactic Survey, secured 60 hours of rare JWST observing time. Led by Anna de Graaf at the Max Planck Institute for Astronomy, the team collected spectra for 4,500 distant galaxies. Within that enormous dataset, they identified 35 little red dots. But one of them stood out. Its light had traveled 11.9 billion years to reach us, meaning it existed when the universe was just a fraction of its current age. When they looked at its spectrum, they immediately knew something was wrong, or rather, something extraordinary was at work. In the region where ultraviolet light should have been, there was instead a violent jump in brightness, a sudden, almost vertical rise in the spectrum. It's the kind of feature astronomers call the Balmer break, a sharp step created when hydrogen atoms absorb light at certain energies. But this break was sharper, steeper, and stronger than anything seen in a normal galaxy. It looked like falling off a cliff, so why not name it that? Now, the cliff didn't just challenge earlier explanations, it broke every one of them. As Anna de Graaf put it, the extreme properties of the cliff forced us to go back to the drawing board and come up with entirely new models. This wasn't a galaxy behaving strangely. This was something fundamentally new. Astronomers soon realized that the cliff resembled the spectrum of one very hot star, more than that of an entire galaxy. That surprising clue pointed toward a radical new idea: the black hole star. We have a black hole at the center, an accretion disk around it, but everything, the entire system, is wrapped in a fixed sphere of hydrogen gas. This is where the model becomes unusual. Instead of dust obscuring the black hole, this enormous hydrogen envelope absorbs and re-emits the energy, acting like a star's atmosphere. Except, there is no nuclear fusion, massive turbulence, and gas that behaves nothing like a stable stellar surface. Yet, the energy source, the accretion disk, heats the surrounding gas in a star-like way. The result? A spectrum that looks uncannily like a single, very hot star, but magnified to galactic scales. This setup naturally produces a steep Balmer break, just like the one defining the cliff. The models aren't perfect, but they match better than any previous attempt. If black hole star objects exist, the cliff is likely the most extreme example, a cosmic enigma revealing a new class of early universe phenomena. And the black hole star idea doesn't solve just one mystery. It may solve another that has been troubling astronomers for years. Why are there so many enormous black holes so early in the universe? Webb has repeatedly found supermassive black holes less than 1 billion years after the Big Bang, far too early for standard growth models. But earlier theoretical work suggested that a black hole wrapped in dense gas, like a black hole star, could grow incredibly fast. If objects like the cliff were common, they may have acted as growth accelerators, allowing early black holes to balloon into giants long before galaxies fully formed. It's a bold idea, yes, but not an impossible one, and it could reshape our understanding of how our universe evolved. The Graaf's team already has follow-up JWST observations scheduled for next year. They will revisit the cliff and observe other little red dots with even more precise instruments. These future studies will test whether black hole stars' objects really exist or whether the cliff represents something even stranger. And when those new observations come in, we'll be right here to follow where the cliff leads next. So make sure you subscribe to Territory, because this is your space.